let's start with the exclusive masterclass that we have today. I would like to first of all welcome our speaker of the day, which is Mr. Peter Birkholz. And I'm thrilled and excited for the session today because the topic is BIM in modern architecture. We are going to be listening to Mr. Peter and his team. Ryan is also here. And let me just give a brief introduction about Mr. Peter. He is a principal at Page and Turnbull. It is a BIM Masters in Modern Architecture. He has over 40 years of experience, and his award winning projects like the Exploratorium exemplify BIM's power in complex adaptive reuse. So, I would like to welcome you, Mr. Peter. And yeah, we are very much excited to see what it is there for all of us, all the BIM enthusiasts who are there right now, who's joined us all across the world. We have around 120 participants right now, and all are joining in. Right. So, welcome. And
Brilliant.
I mean, you can share your screen. I will stop sharing.
That sounds perfect.
Okay.
I just need to do the handoff here. Hold on, please. Brilliant. So thanks a lot, Devashari, for allowing us to present here today.
My
The
pleasure.
title that you have given us is the BIM in Modern Architecture, and I'd like to take it a little bit in a different path here and talk about the past, present, and future of BIM, and in particular, the documentation of historic buildings and in laser scan to BIM process. Um, as you mentioned, I am Peter Birkholz, a principal with Page and Turnbull in San Francisco. We're an architectural firm that have been around for about 50 years, the first architectural firm on the West Coast of the USA that specialized in historic preservation. And in our 50 years, we've done a lot of recordation and documenting of historic buildings. And I'll talk a little bit about that process as we go forward. Joining me here today is Ryan Henderson, and Ryan is just coming back from a vacation. He's either well rested or he's super tired and jet lagged.
A little bit of both.
But Ryan, if you want to tell us a little bit about yourself and your company.
Sure. So my name is Ryan Henderson. I'm president of Locust Laser Scanning and also Locust Architecture Studio. Started building houses with my dad when I was 8. Kind of always knew I wanted to be an architect, and have always been into high technology. I was thinking actually on the drive here about my first computer was a Commodore 64, and it changed my life when I was a kid, and it continues to do so today, as it is probably for a lot of us. And 3D scanning has really taken over how we do things in our own office. And I couldn't help but just share the power of having high density measurements that basically become a 3D model exceptionally quickly in a manner that had never been seen before, just as short as a decade or two ago. So very happy to be here, and looking forward to telling you and the rest of the audience about what probably a lot of people still don't even know about. So thank you so much.
Thanks so much. And also with us today is Yuhan Jiang of NC-A&T. And again, I wanted this to talk about sort of where we've been. Ryan's going to talk about the current practices, and Yuhan, I'd like him to talk about the future of BIM. Yuhan, tell us a little bit about yourself.
Yeah, hello. Hello, everyone. This is Dr. Yuhan Jiang, assistant professor from North Carolina A&T State University. So technically, I'm a assistant professor to handling the core course for the construction management program here at A&T, and within the CM umbrella, we do a lot of virtual design and construction. So the interesting part here is we do a lot of scan to BIM practice and also research and try to involve the AI. So today I will share more about how to use the AI to facilitate the scan to BIM process. Yeah, looking forward to talk with you guys.
Yeah, and I'm super excited to learn about the future, and AI is certainly a big part of that. So where have we been? Measuring buildings and measuring. We sort of put the U.S. measurement of a foot's roughly based on the size of a foot. We've used sticks. We've used, wood rulers. We've got into distos at some point, and now we're using lasers, etc., to measure buildings. It's all changed, and I think all of this has changed dramatically in the last 20 minutes. And in the sort of lower right here, you see a profile gauge, and where we still rely on tape measures often. We still use distos. We do incorporate laser scans into our process, but often for some of this detail, when we don't have the money to pay for the laser scan to BIM, we use a profile gauge, and it comes down to manual drafting, which is laborious. And I think the future with AI will speed all of this up dramatically. Again, how do we do our work? We go out, when we're not doing the laser scan to BIM, we use binoculars, we get on swing stages, we measure things. We take old drawings, we mark those drawings up, like you see on the right. We take that back to the office, or we send it to a consultant, and then the typical process was manually putting that into CAD or Revit or something like that, and getting some sort of a line drawing that can be used for the documentation going forward. Incredibly laborious, and prone to inaccuracies. More examples. This is a building up in Napa that we're working on currently, and this is a field drawing where somebody's gone out there and measured things and gone back into the office. So where we can, we do incorporate laser scanning in. Again, looking back to where we used to be, this is something I found in our archives where in the 80s, this is a building in the oldest buildings in Oakland, the commercial buildings, and the process then was to go out and take orthogonal photographs, take those negatives, tape them together, send them out to the blueprint place. They put them onto Mylar, and then that became the basis for drawings that you see on the right with lots of hand notes. So in a very short time from the 80s until now, where we've gone to hand drawing to CAD to now Revit, things have changed a lot. I do want to mention that it's kind of ironic that one of the things in a heritage work that we do is the Historic American Building Survey. And the Historic American Building Survey has been around since the 1920s, recording prominent landmarks in the US. And they rely, and they still request, that these kind of line drawings, which are interpretations of the buildings, not incredibly accurate, but somewhat of a facsimile of the building, is the method of recording that. And so somebody is paid to do this sort of documentation, and then these drawings are printed archivally and they're put into repositories. A lot of the work we do in California has to go through the environmental laws, and we call it CEQA, California Environmental Quality Act. And often buildings that are being demolished or altered, we have to record those as a mitigation for CEQA. And again, typically the status quo has been to just document these in paper drawings. We are now seeing the things moving towards laser scanning and Matterport scanning, which I'll talk about, and putting those into some kind of archival form. But I think the thought, and there's also Historic American Building Survey photography as well. But the idea is that all goes into a repository that's sort of archived forever. But we are seeing a little bit of change where these sort of newer technologies are able to be used. And I would say that the drawback on the newer technologies, though, is you have a large digital model, and how does the public access it? And how in the future is that digital model, the format of that digital model, going to be a program that people have available to them? In the work at Page and Turnbull, we've done small projects, we've done big projects. This is a project called the Oakland Monster, which is, we didn't really have a use for laser scanning, but we did laser scan it anyway. As you can see, it would be a hard one to sort of measure with tape measure. And Ryan, I think you did the laser scan as a pro bono for us for this one.
Correct. Yeah. This is probably top 5 weird scan projects for us.
Yeah. And the reason we had Ryan scan this was that we wanted to be able to push technology and producing models and facsimiles of this. And we were able to take that scan, Ryan, and I quite frankly can't remember the process of taking that scan and converting it to a file that ultimately got us to that STL file where we could print a small model of that. And I'll show you, I have one sitting here to the side, but I'm not going to go grab it. The larger scale of projects that we're doing, Paige and Turnbull is on the team for the California State Capitol Annex of $500 million project in Sacramento. And this project started like 4 years ago, and we've relied heavily on laser scan to BIM. And I'm sorry, I'm Ryan, but Trimble got this one. And we're using it, just we'll talk about the uses for laser scan, but a lot of what we've done is on the back side of the building where you see the blue square where the new addition's going. We've been replicating ornament and recreating ornament on the back side of that. A reason for potentially using laser scan, this is a project we did many years ago. It's the Desert View Watchtower on the edge of the Grand Canyon. And as you can see, again, the sort of non-orthogonal shape makes it hard to measure. The laser scan also allowed us to go out over the cliff and measure all sides of the building. And from that, then we had this sort of digital twin that we could come back into the office and do our production of our restoration drawings. I mentioned a Matterport scan. Matterport scan is often another deliverable that happens. And the beauty of a Matterport scan is that we're working on, say, the Desert View Watchtower. Point clouds are hard to manipulate and sort of look at, but the Matterport scan gives a readily kind of virtual room by room sort of twin that we can walk through and sort of look at existing conditions. It's funny, I was trying to pull up one of our projects. This is not one of our projects, and I got this when I went to find our project. So an issue with Matterport scans is you pay for the Matterport scan to be hosted in the cloud, and if you don't pay for it, you lose your cloud. And so that particular scan was not available at the time when I went to kind of go look at this. Projects we've been working on. This was a 2010 project that started in 2020. It's the Glenn County Courthouse. You see in the center of that circle, that historic building off to the right. When we started this in 2010, and here you can see before kind of the 2010 images, a nice little kind of square building. And actually, interestingly, because it's the exterior walls are solid brick with no voids, an easy one to sort of laser scan to BIM. But unfortunately, at the time when we started that project in 2010, we weren't really using laser scan to BIM, and we had submitted our fees to the client, and we did not include that fee as a sort of deliverable. So we took, you see this old drawing from a 1980s renovation or 1990s renovation. We took that drawing, converted it into perhaps CAD at that point, 2D CAD, but then quickly into Revit, and then verified things in the field with tape measures and perhaps laser scans. And I remember somebody, a junior staff person in the office, saying, "Are we going to use laser scan to sort of document this?" And I jokingly said, "No, all we can use is rod and chains," because we didn't have the fee to do it. And one of the issues that, the beauties of the laser scan to BIM, and Ryan can sort of talk about this a little bit when we get to him, is that exactly, there's this, you see this center corridor in this area here with doors off of it. One of the issues that came up is like we're measuring it and it's like, yeah, there's a door here, a door here. This door, say, was 12 inches vertically in the other direction, and it intersected with a wall that we put in the future. And so you miss things, right, when you're going out and measuring, where yes, you've got a door, but where's exactly that door on the plan? And so it became a CA, a construction administration problem in coordinating how big is that door, where is that door. But since 2010, we have been exclusively going to the scan to BIM type process. And here one of the other beauties of scan to BIM is you get a lot of detail. This is a rendering that we produced in-house from our Revit model. And you can see it's a little flat, not a lot of detail. You get a much more detailed product when you go scan to BIM. Another project we did, and this was an interesting one in that, did you do this one too, Ryan? Yeah.
Yeah, I sure did.
Uh,
This was a little bit of a rabbit warren, lots of levels,
yeah. And
deceptive.
so uh, a 1920s, two hotels next to each other. And the issue with these two hotels next to each other, you see on the left this bigger block, and then on the right, you see this smaller block. And in the section here, you can see um, I put a section line across here through the center, but the floors don't line up. Each one is about 18 inches. The floor to floor height's 18 inches different. And the issue became, I believe, Ryan, that we didn't scan it as one model. We scanned it as two or vice versa. And so when we went to do our Revit model and we were cutting putting the floor plane in some cases, it would have part of the sixth floor and part of the fifth floor on the right, or vice versa. And to even complicate things further, we were working with a drafting firm in India that was helping us with the drafting because it was in COVID and we were like incredibly understaffed. They started masking floor areas to sort of make the plan work so that everything was on the fifth floor that should be on the fifth floor. We didn't know it, and it just became like major confusion. It's like in the future, always scan these things as one model, I think was the lesson learned. Brian, I'm going to let you talk about photogrammetry and laser scans perhaps in more detail. And unfortunately, Ryan, due to the timing, I could get a lot of pictures into your slides, but I'm hoping you can fill in words. We're going to talk about BIM conversion to Revit. I'm actually really curious, Ryan, on how the heck does that happen? Is it automated or is somebody really sort of tying all those points together? We'll talk about how much detail. I think the benefits are as you get accurate dimensions on your computers, you've got the virtual twin on your computer. You don't have to go back to the site. Like if we're going up to the Grand Canyon or something from San Francisco, we've got that picture and the point cloud that we know what it is. We don't have to go back for additional visits unless something happens to the technology. We have to redo it. It allows for QA such as clash detection that we can do, and you get a lot of precise details. And I think one of the interesting things that we have on historic buildings is that important that it captures out of level and out of planes. For instance, buildings over time have settled, and we've got a tenant coming in that wants level floors, but we don't even know they have level floors when we're doing with the tape because it's very subtle. The laser scan will capture all that. And if we're doing a new addition and the walls of the building are slightly out of plane and we've got a new curtain wall going, we can accommodate that sort of out of plane differential with some sort of a joint that is, say, bigger at the bottom and smaller at the top. Lessons learned, when you want to do it early, you want to scan everything, scan behind. And I think another issue we had, Ryan, on that St. Clair or the Capitol Park Hotel was, so that was a single room occupancy, which is for those of you who don't know it, it's a hotel for sort of transient and the sort of lowest cost housing that's available. In COVID, there was a huge demand. There was a lot of homelessness, and they really wanted to keep that building occupied and only take people out of it once construction started, which meant that we couldn't get into the building and scan early, and we couldn't do our destructive testing. So therefore, we couldn't poke holes in walls to know what's kind of like the wall construction is. And Ryan's scan was kind of surface because obviously if you're scanning a room and you've got a drop ceiling, the laser scan can't see above that drop ceiling. In the ideal world, you'd poke a ceiling tile out or poke a hole in the wall and put the laser scan in there, and it can see in the dark and it can kind of capture that information. We didn't have that ability. Another lesson learned is, is like when we're measuring, say, I showed you those elevations where somebody's hand marking a window and we mark like type 1 window. Each window on a historic building can be slightly changed and slightly different. And for us, as documenting it with a tape measure and sort of the disto, we'll just say it's all the same. But in reality, they may be slightly smaller, slightly larger, that everything is not actually the same, typically. I'm going to just do a quick talk. Diveshari, how much time do we have for this?
Sir, you have around 30 to 40 minutes more.
Okay, that's fine.
And it's okay, even if you want to continue for like 45 minutes or 50, it's all right.
Okay, I've got just a brief bit in here that I want to put in that I was kind of just fascinated by this technology and where the heck did it come from? So I was like researching it online. At the bottom here, I show you a few links to YouTubes and other things. There's a fascinating history on the web about this. But interestingly, and we're talking about in the US and cutting federal funding because everybody should just be able to pull themselves up by their bootstraps and invent technology for free. But a lot of this technology came out of research institutions and US labs that are with a lot of that funding coming from federal funding. So all of this technology and this efficiency we've been able to harness in the last 20 years came out of these labs, with the first lab coming out of MIT. There's a laser that's shooting back and forth. I truly don't know how this all works, but that circuitry came out of the Los Alamos labs where the nuclear bombs were developed. The point cloud was an idea out of UC Berkeley. Pulse technology for the laser came out of University of Vienna. The other interesting thing to note about these technologies, and I put in parentheses this name Regal, is that a lot of the professors at these universities that did discover these things were the first people to then spin it off into the private world. And Regal was one of the first developers of a laser scan, one of the competing products that happened. I also thought it was really fascinating that Sierra, which was a Walnut Creek-based firm here in the Bay Area, which later merged with Trimble. Sierra really was doing the laser scanning thing. Trimble was focused on GPS signals and measuring GPS signals back and forth to satellites and using that kind of technology. Those two merged, but they were coming from this technology hub of the Bay Area, which I thought was really fascinating. And then we later see that this sort of technology is used in robotics because robotics need to see and know where they are in space, and in autonomous vehicles such as the famous self-driving Tesla, which we're waiting for. What can we use laser scanning for? 3D as-built, replication of existing objects and elements, archaeology and heritage documentation, QA, management of, large commercial real estate people can do laser scanning and they know what their properties are. And then it's spun off into video games and virtual reality and artificial reality, the film industry and forensics. And Ryan, perhaps when we get to you, you can talk about how many of these other peripheral industries you've worked with. Another fascinating thing is there's this group called SciArc, which was been around for more than a decade, and they've been going around and documenting World Heritage sites. And some of those sites that they have documented, for instance, when the Taliban was in power, that they destroyed, that's the only recordation we have of those. So it's really been wonderful for the documentation of heritage. And this process was originally not developed for us little architects doing houses or buildings. It was developed for industrial applications, oil facilities that are incredibly complicated, nuclear facilities that are really difficult to get into. They were also the funders and sort of the first purchasers of this equipment. And what we've seen is that there's been an increased trend towards devices getting more portable. One of the documentations I was listening to on YouTube was talking about the first device that Trimble came out with. And when people wanted to see it, they would have to ship it on a pallet and in a big crate. And it was incredibly fragile, and they were really worried about shipping it because they only had one, and would it get destroyed? And so we're seeing things becoming more portable, the ability to do it over greater distances. It's become more accurate with higher resolution and lower cost. And there's improved software integration and then increased field of view. And what I'm talking about in field of view was the initial ones could only sort of see a very narrow band left, right, and then later up, down. Over time, it's kind of gone 360 and up but down vertically into 270. I don't know if they're at 360 yet, Ryan. You could tell me that. I think I talked about all that. And so some of the first scanners, the Mency scanner was the first one. It could only scan 10 meters out. It required a gas-powered generator to power it, so not very portable. In the 1980s, Sierra or Xerox, which later merged with Trimble, had the first portable scanner. And here you can see that battery pack is not truly terribly portable. Leica then sort of picked things up and had greater accuracy, field of view of 40 by 40, more compact. And then the field of view 2006 got better, up, down, left, right. And here you see Regal, which was one of the early people documenting a heritage site, which I thought was just kind of fascinating. And I'm not going to get into this, but Ryan, I would like to hear from you when we get into this. What was your first device and how much it cost? Because I think the early devices, were hundreds of thousands of dollars, and now they're significantly less than that. And all this happened in 20 years. I think it's just amazing what's happened in 20 years. And now, Ryan, I'm going to let you sort of talk about where you've come from,
Sure.
And what you've been doing.
All right. Thank you so much. If it's possible, I can share some slides. I can just kind of blast through a couple of things from a presentation that I've got pulled up, if that's okay.
I will stop sharing.
How's that?
I can see it.
Okay, beautiful. This is a presentation that we give that's usually about an hour long, and so if it's okay, I'm gonna whip through this pretty quick. Peter's covered a whole lot of things already, and I'll just pick up. I'm gonna talk over these slides, and people can read just so they're on the recordation. So Peter, very detailed. Thanks for that. Kind of brought me back to the early days. We did actually start with a Faro 330. You can actually see it right here.
And what was the price of that, Ryan?
Out the door, the figure we all throw around is basically 100 grand.
Yeah.
I was lucky enough that I had a bit of a real estate investment windfall, and I knew this is where everything was going. And I had just decided to launch out on my own, and I needed to set us apart from other firms. And this did it. Unfortunately, in some ways, it did it in terms of providing scan to BIM services, which trumps our architecture services by a fair clip, which is totally fine. However we can provide service to move forward, design and building technology, I'm all for it. We had actually worked with SciArc in the early days, doing some historic recordation here in Sonoma County, where we're based. Here's a great slide of sort of what we used to work with versus what we work with now. So this was a project in Malibu on the beach, and so on the left is sort of standard, very low information civil survey, and then on the right was our laser scan, which has literally every stud, every screw. Sometimes that can be too much, and so one of the skills for scan to BIM providers is to just get down to the details that actually matter to the project. The scanner doesn't care if you're capturing a ornamental detail on a building or the gaps in the wood on a pallet rack. It does not care. It will measure it if it can see it. So one thing that we do come across quite a bit is that buildings are not true plumb and square, have yet to get one yet. However, Revit really wants things true plumb and square.
Yeah.
And so even in this project right here, this is an overlay from the scans in red and the BIM model, where there's a saddling of the whole roof structure was happening. And this was actually presented to the insurance company after a tree had fallen on the building, and they got a little bit more funds out of that one. This was an example of like some floor flatness scenarios that Peter was talking about earlier. We've encountered those for medical office buildings where everything needs to be very flat. Older buildings in San Francisco that have lots of differential variations in floors due to the technology not being the best in terms of forming and pouring and helicoptering slabs and things like that. So this is a quick example of pre and post earthquake where the building we analyzed it and actually torsioned about a whole inch. And we could also identify individual cracks before and after using orthogonal photogrammetry from the laser scans. Some nice thing is being able to overlay new designs into old designs. This was a project where the neighbor was complaining to the planning department saying that they're making the building bigger, it's going to block her views, and they showed those images and said no, it's actually still within the same envelope. This was some of the things that laser scanning people think they can do is like X-ray, like see through things when that's actually not the case. However, if you scan at certain points of time during a project, you actually can effectively see through buildings. In this case, this is a pre-slab pour of underground or in-slab heating elements. And so we wanted to make sure that we knew exactly where all of these tubes were and also where the rebar was. So when they were doing embeds or posts or handrails into the slab, they would not hit pipes that were in there. Blast through some of these. This was an example of some above ceiling scanning. Peter mentioned that as well. When possible, it's a good idea.
Ryan, you got plenty of time, so
okay, good. It's a good thing to do. Unfortunately, it is somewhat cost prohibitive because it's a ladder operation. It's having somebody remove ceiling tiles and put them back in some cases. Ideally, we like to, what we found does work is if we scan below ceiling, maybe take a couple of scans above ceiling just to get the structure above confirmed. And then if it's possible to do a design build package for MEP after a demo phase has happened, then that we found works pretty well, and it keeps our costs down because above ceiling scanning it basically doubles everything for sure. There's a couple of different products that we use, and this is from Faro and provides remote viewing, sort of a la Google Street View, but of your project the day it was scanned, and you can scan everywhere our scanner is set and take dimensions remotely, which has been, I know, a big help for us and other firms where it cuts down on the number of site visits, the number of interruptions made. And for us on the modeling side and on the design side, having the project up on one screen where you can move around and take measurements from it and notations and screenshots is highly valuable.
And is that a point cloud, Ryan, that you're measuring?
It's technically not. It's the panorama image is what you're looking at, but there's basically the point cloud data is stacked behind it. And so you can take measurements of the point cloud, but you're not actually dealing with the visual weight or the navigational weight of that point cloud like you are in Recap, which is Autodesk product that integrates with Revit. That can be a little cumbersome. And so this is a Trimble product, which is a little more lightweight.
Yeah. And Devashri, Nuran, somebody had a hand up. I think we'd be fine with people asking questions at points.
Yeah.
Perhaps you could put your questions in a chat.
Yes. So we've asked the participants earlier. I mean, they can ask all the questions in the Q&A. And yeah, we can take it up later.
Maybe. Perfect. Thank you.
All right.
This is a small example of what we see all the time, which is we are we're told the architect says we really want a laser scan. The client doesn't want to pay for it because they already have CAD drawings. But we know that just from visiting the site, those CAD drawings aren't accurate. And so it usually takes a little bit of explanation as to why their CAD drawings are not accurate. And then we'll show them a slide like this, where, hey, your storage closet is completely not what it is. The elevator's not where it is. There's columns that are there that are not on your plan that have a huge impact on what you're trying to do. And that usually shakes them loose.
Yeah, and in that particular instance, because what we perceive is we think we do have an accurate thing, and we look at that CAD drawing and we go out there and it's like, yeah, it's captured it, but the reality is it doesn't.
That is true. And it's hard to field measure like a building like this
Yeah.
and get, every angle of every, seismic brace and, every rope pulley for a full proscenium, fly and stage and all those things. Um, Here's a brief example. So sometimes authorities having jurisdiction will, on the planning side, for larger projects, sometimes ask for shockingly unreasonable things, but warranted. In this case, it was give us every elevation of every house for an entire square block around the entire project. And a client would just lose their mind. It's like, well, I'm not paying for that. And so we actually were able to just pull it from the scan data that we were doing from the project anyways, and presented it like in this format, which was acceptable. Hopefully a more reviewing agencies will start embracing um, point clouds as a deliverable, or at least the images from them as deliverables, because sometimes they're only used to vector drawings. They're only used to that, which is great. But I think the one on the left and the one on the right combined is really, provides the most amount of information on a building, for sure. So this was a case where it was a post-earthquake and they had to remove every stone of the building and put it back in its original location. And so we scanned it and numbered it and turned it around in, I think, just like 48 hours. Very quick timeline.
Wow.
This was another floor flatness analysis where we can get down to custom contour settings, both visually and color coding, and then also in CAD drawings. I like showing this one because this was a pretty tight, like 6-inch contour. So, and this is just basically raw data. So it hadn't been fully cleaned yet. But on the left, you'll see all these little tiny dots in some of the larger areas. And that is not the ground. Those are weeds. That because they hadn't mowed the lawn. And they came through in the topography. So sometimes you have to really scrub your data too to get good data. But I was like this is when we're working, we see this first before we actually can, go in and clean everything out and give the end user what they need. So this is a project we're never going to do again. We fired every CAD client we have, except for some landscape architects. I'm kind of at a point now where, and I started in Revit in like 2006, 2005, something like that. Been doing BIM since like 92. It's 2025. If we design 3-dimensional buildings, and yes, it can be done in 2-dimensional representations, but those can cause some issues. And so we 95% of our clientele is Revit based, and we utilize ScanDBIM stuff, all the time, obviously. Here's an example of some residents, that's again quite difficult to capture in a 2D format, but we were able to get down to, all the framing members and all that stuff. I can talk about it now, thank God. We've worked with some pretty high-tech companies over the past decade and a half or so. One of which is NVIDIA, and we've worked with them on a handful of fairly large projects. And that was our first foray into some of the AI, not AI, but mixed reality, porting point clouds to VR headsets, so you can do fly-throughs from 3D scans and things like that. That is somewhat where I think things are headed, but we'll see. VR is kind of already getting surpassed, if you will. This is just to give people kind of a rough idea of what some of the costs are. Every project's different. We say, we can capture a 3-story walk-up apartment in the same amount of time that it could take to do a whole auditorium. Just because the way laser scanning work is that it's line of sight. And so if you think about it like a firework exploding, if you have a big area, then you're going to cover a lot of that area in one scan or just a handful of scans. Whereas if you have a bunch of tiny little areas, you're going to be using little tiny fireworks, and you've got to use a lot of them to cover all those areas. So I'm going to spend a little bit of time on this. I know it's text heavy, but we'll hit some highlights. Peter's fantastic, and I love working with Page and Turnbull, and Peter's known for his highly detailed queries for projects for us. And so sometimes I'll get an address, and sometimes I'll get a picture. But a lot of times it's, hey, can you go out and scan this for us? And I'm joking. Sometimes it's more than that, but a lot of times it's not. It really is just like, here's the address. Can you go give us a model? And so that usually kicks off about a 5 or 10-minute phone conversation, and that's usually kind of all we need. We want to make sure that we understand the goal of the overall project. Just because we can scan and provide very high detailed models doesn't mean that we need to. When we were first starting out, that was one of the biggest complaints that we would hear, is that designers and architects and engineers were getting scan to BIM models from civil engineers who thought that providing every variation in the building and recreating it in BIM was a good idea. And what that leads to is unmanageable, uneditable drawings with lots and lots of clash collision problems and items being deleted as soon as you touch them, and can't pull dimensions and all kinds of very problematic models. So one of the things that we focus on, and that we have instilled with other laser scanning firms that we have brought into this arena, is to be sure that we understand what the goal of the project is, and that we're only scanning and modeling to that, and that we're not going necessarily overboard. It's nice if we know if there's things like if the building's going to be fully gutted or not, if the MEP items are going to be remain or added on to. Is it important to know where every outlet, every switch, every thermostat, every fire alarm is? Because that adds cost both on the scanning side and the modeling side. Usually those aren't needed. And a lot of times the consulting engineers, they want to do their own investigations. So that's kind of how you can help us help you guys, is by providing as much detail of the overall goal of the project. And if you're with a good scan to BIM company, they're going to know what they need to do in order to provide a deliverable that's going to meet that. Maybe one other thing to touch on is how we convert that. And so go to this last little slide. So here's a, scan to BIM overlay. And because buildings aren't true plumb and square, they vary. And so we like to pick sort of a best fit approach. We do use software that integrates with Revit that allows us to effectively pick a wall in a point cloud, and it will take the limits of that wall and then create the wall in Revit. The problem with that, and there's programs that you can just shoot at a point cloud and it will spit you out a Revit model. What we have found is that the time to go back through and QA QC that model to make it actually accurate, to catch those 10% of things that aren't really what they need to be, takes just as much time as if we do it from scratch. Also, one of the things that's missing is the architect or engineer's mind frame of how the building is built in Revit. Does the wall sit on the floor, right? Does the floor slab go into the wall or not? Is there an indication of a footing or not? So all of those type of decisions that the scan to BIM provider has to make in order to provide a model impacts the design team for sure.
Yeah, good.
Do you see it?
Yes, I see it. So currently here in these slides, I've showed two pictures. So one on the left is myself standing in front of the engineering building for the Marquette University at the Wisconsin campus. So we typically using a previous older vision drone, the Phantom 4 Vision 2, as you see on the grass. And on the right side, we see a LiDAR scanner. It's called the Foxtech Slam 100, and also with its 360-degree cameras. So that is a mobile system. So the cost for the drone is kind of like the cheaper, like $2,000, $2,000, and for the mobile LiDAR system, the cost will be run up to $1,300. So it really depends which part you want to keep, and for the mobile LiDAR itself, it's costed $20,000. Sorry, and then for the puncture LiDAR, the camera system is additional $100,000, and for the RTK or the GPS system is $5,000. So this system right now is offering the second version called the SLAM 200. So if you want to searching, you can type in the SLAM 200, SLAM 200 on the Google. You will find out who is offering this one. So, and they do have some other companies offer the similar products. So it's good to see how it works on the next slides. Yeah, so I'm currently as an assistant professor at the North Carolina A&T State University in the Department of Built Environment, and I'm also leading the visualization and the collaboration lab. So the lab goal is to develop the automatic process for scan to BIM and using the AI as a power assistant. So in the umbrella of the scan to BIM, or we can see something else different now is called digital twins, or the virtual model and the physical model together. We have a digital twin models. Here, they have a lot of technology has been involved in these scenarios. For example, we have talked a lot about the ladder. So the ladder can be the terrace ladder as the regular one, and also can see this is a mobile SLAM one. And depends on how we using the ladder. The ladder can be stand on ground, or even how can be carried by the drone, or even how can be carried by those robotic dogs. And this is kind of we see a process to collecting the data. So once we collecting the data, we need to think about how to using the software like the Revit or the even how the Trimble SketchUp, right? Usually called Google SketchUp, to convert those 3D points into a model, 3D digital model or called BIM model. And also, we talk more about the building scenario we have using the BIM, but for a lot of the large built environment, for example, transportation, right, or the community-based or the landscape-based, we were using more like the GIS. So, and we can combine the GIS and BIM together to show the BIM model or the digital models for community or even how city levels, right? So to process the data between the ladder point cloud into the BIM, we were using the power of the AI. I'll talk about this process later, but I kind of give you overall idea how those process looks like. And finally, when we're getting the BIM model available, as Ryan just talked about it, there are some virtual reality, augmented reality, or even how called mixed reality, and we can using those to visualize the models, either the design BIM model or either the scan the point cloud model. Next slide. So here currently something different to the laser scanner. We have something called the photogrammetry. So the photogrammetry is very powerful. As before I started to using the ladders, I spend a lot of time to dealing with the photogrammetry. The photogrammetry means you using the drone to scan the sites or scan the buildings and process the data, and basically is an image process and a 3D reconstruction based on the images. Then you are getting very, very accurate and also very, very colorful models. For example, we can see the 3D model left corner, and also can see the 2D images over here as well. So with those, we can do the same thing as the ladder scanner results. We can do the measurement. Next slide. So here is the example for the vertical construction. We call the buildings a vertical construction. We can fly the drone. You can see the price for the drone is not expensive, and also we can definitely use some cheaper and affordable drones like DJI Minis. So we have updated DJI Mini to the Mini 4 Pro, but the cost is still close to this. To scan the buildings, you will fly the drone to around the buildings from the bottom to the up, and definitely you want to scan some for the roof. So the angles will be facing the buildings, or even how you change to 45 degrees facing the buildings. And as you can see from the those image and the shorting station positions as well, and then you can get a point cloud. So that is similar to the laser scanner or the ladder results as 3D points. Next slides. So definitely there's some example. We talk a lot about those terrorism ladder scanner over here, and also some of the drone carried ladder scanner. And also, if you do have a mobile phone like iPhone Pro or even how the iPad Pro, you do also have your ladder scanner available. You can go ahead to download some apps like the 3D scanner app that is totally free, and then you can generate your point cloud results from your mobile phone directly. And also they do have some app called Pix4D Catch is using your mobile phone to capture the images and then do the photogrammetry process. You are still getting the 3D point cloud results like the app one here. So you compare with the two, you will see the advantages for the laser scanner is it can quickly get in the point clouds and can try to cover as much as you can, because when you capture it, you can see which part you have captured. But for the photogrammetry, depends on the quality of the images. Once you when you finish your scanning, but you may not sure whether this has enough spectral point and then can make the image dense enough. And if you have a missing part over here, you will see this a big hole for the grassland over here, but it's also able to add in the new images in, and then you reprocess and will be give you more detailed results than that one. So so to my eye is the LiDAR scanner, you will scan the sense, you will get it, but photogrammetry is even how you take the picture of it, you may not able to get it, then you need to repeat this process to make it more in the good qualities. Next slides. Yeah, next one. So once we getting all those data, we will think about the two process, right? To the BIM process. Once we scan, we get a points, and then we will think about how to convert those points cloud into the BIM models, or even how we using the photogrammetry, how can we convert those mesh models, is still in 3D, not like point clouds, into a Revit model, or even how 3D wireframe models. Next slides. So in this one, yeah, maybe click one more to let the video going. Yeah. So in this one, you will see this is kind of likely using the Microsoft HoloLens, the Vision 1 to overlap a SketchUp model on the physical stairs over here, and then you can walk over it. And this is more likely you can think about the redesign, right? So next slides. So in this video, and since we are doing something history building documentation, and we were trying to facilitate the process, how to using the either photogrammetry result or the LiDAR scanner results, and powered by the AI to generate the model automatically. So from the beginning of the video, you see is a 3D mesh model. And for here, you see how the algorithm is tracking all those floor plans. And for this one, it's showing how the AI is able to finding all those windows. And then this one is showing how the AutoCAD is going to using the finding the data like the window schedules to set up the slides to creating the 3D wireframe models. And definitely we can do this in the Revit as well. So in the next slides, we will show a video about how to do this in the Revit. Yeah, next slides. So for here, it's the same process. So Peter, can you click the close the floor plan? Yes. So yeah, yes. So the first one we're going to identify all those corner points, and then we can using the algorithms to find out the floor plans. And in the bottom one, you see this is a dynamic modeling. The video is playing, and you can see the Revit model has been generated. Once we zoom in, and we can see this is a brick wall. And also we can find out those crackings has been identified by the AI, has been mapping into the Revit model. And we definitely can checking out the parameters like the length and the thickness of all those crackings. Yeah.
And Yuhan, on this dynamo modeling and those cracks, can that be exported to some sort of a schedule where that can be quantified?
Yeah, definitely. Since for each of them, we have already we already has its length, we have its thickness, and we can do two-way, because when we try to modeling it, we definitely have all those information in the table like the spreadsheet, right? And then we can share this one with the inspectors for the documentation, or even how to do the repair. And another way is we can export this one from the Revit as a schedule, like a window or door schedule you showed in the previous slides, and we can do this as well. Yeah.
And that process is like overnight? You set the program and it's pretty quick, or is it in seconds?
Yeah, that's
or?
that's currently just a couple of seconds will
Wow.
generate those models. Yes.
So I think that's it for today, but it was an amazing and insightful session. Peter, Ryan, Yuhan, all three of you. I think even I'm a PhD, Yuhan, in structural engineering. So, what I did is I have done earthquake analysis of the buildings where I have developed the plastic hinge models. So, Peter, I'm telling you, the insights that I've got, maybe looking forward in the future, we can also do some research in the front with the students. Yeah, and every practical details shared by you, Peter, along with Ryan, that is all very helpful, and Johan and you as well. So I would like to again thank you with all the warm hearts, and we are grateful from TechnoStruct group of companies that you have joined us and have shared all the insights with the people all around the world. We were around 270 attendees, so I think all of them have gained a lot. So yeah, thank you. Thank you to all three.
Yes,
Well,
thank
thank
you.
you so much.
Thank you.
Thank you, Peter. Thank you, everyone.
Have a good
Thank
day,
you
everyone.
to all the attendees. I think you all have got the email IDs of Mr. Peter, Mr. Johan, and Mr. Ryan. And what we can do is we can also share the email IDs with all of you later. So thank you.
Bye.
Bye
Thanks,
bye.
everybody.
Thank you.
Bye-bye.
Bye bye.